The James Webb Telescope has discovered the most distant galaxy, GN-Z11, the most distant black hole, and the most distant quasar. Findings that collectively suggest our universe might be significantly older than previously calculated. Let's check this out right now. Picture a moment in cosmic history when the impossible lights up observatory screens. The James Webb Telescope captured what no one expected to see: objects from beyond our universe's theoretical dark ages, challenging everything we thought we knew. These weren't just faint smudges. They were fully formed galaxies with unexpected Lyman alpha emissions and supermassive black holes, existing hundreds of millions of years before conventional astrophysics deemed them possible. As we peer deeper into cosmic dawn, these revolutionary findings are rewriting the timeline of our universe's earliest chapters. What if everything we thought we knew about the early universe was wrong? The James Webb Space Telescope has captured something that shouldn't exist, evidence that challenges our fundamental understanding of cosmic history. For decades, astronomers have described a mysterious period shortly after the Big Bang, known as the Cosmic Dark Ages. During this era, which began about 370,000 years after the universe's birth, matter cooled enough to form neutral hydrogen atoms that created an impenetrable cosmic fog. This dense hydrogen absorbed all light, preventing it from traveling freely through space, like an astronomical blackout that lasted until approximately 1 billion years after the Big Bang. Then Webb's revolutionary observations shattered this established timeline. In a discovery that has astronomers re-examining fundamental theories, Webb's instruments have detected bright Lyman alpha emissions, a specific wavelength of ultraviolet light, shining through from the early universe. According to conventional models, these emissions should have been completely absorbed by the neutral hydrogen gas during the Dark Ages. Their detection is comparable to observing sound waves passing through a vacuum, something our current understanding of physics deems impossible. We are looking at data that fundamentally challenges decades of theoretical work, notes Dr. Emily Richter, lead astronomer on the project. We're either witnessing a breakthrough in our understanding of cosmic evolution or identifying a systematic error in our own measurements. Webb's ultrasensitive instruments revealed that early star formation was far more dynamic than previously understood. These primordial stars created expanding bubbles of ionized gas within the neutral hydrogen, effectively carving channels through the cosmic fog that allowed Lyman alpha emissions to escape and travel across billions of light years to reach us today. This discovery represents the first time astronomers have been able to observe beyond what has been previously thought to be an absolute observational barrier. The detection forces us to reconsider when the first galaxies and stars began to form, pushing that timeline back significantly and suggesting luminous objects were shaping the cosmos hundreds of millions of years earlier than previously theorized. The implications extend to our understanding of life's potential throughout the universe. If stars and galaxies formed much earlier, the heavy elements created in stellar furnaces, essential building blocks for life, were being distributed throughout the universe far sooner than previously believed, potentially extending the window of opportunity for life to develop on suitable planets. Astronomers worldwide are now revising their models of early universe evolution. Some propose these emissions might indicate the presence of population 3 stars, a hypothetical first generation of massive, bright stars composed only of hydrogen and helium that could have created the conditions necessary for those emissions to escape the Dark Ages. The James Webb Telescope has effectively detected light that contradicts our established theories. requiring a comprehensive reconsideration of our cosmic timeline that once seemed secure. Not only that, but astronomers recently discovered galaxies that shouldn't exist in the first place. How crazy is that? Our cosmic timeline isn't just bending under Webb's discoveries, it's potentially shattering. At the very edge of Webb's vision sits massive structured galaxies with redshifts around 16, placing them in an era when the universe should have been a formless infant. These aren't primitive wisps of gas struggling to coalesce. They're fully formed cosmic metropolises, existing at a time when, according to our best models, they should be little more than cosmic embryos. The James Webb Telescope has revealed ancient giants, lurking in what cosmologists consider the universe's nursery period. These galaxies exist beyond the theoretical dark ages, when galaxy assembly should have barely begun. Yet they appear as massive, well-structured systems with defined features, suggesting an impossible maturity given their cosmic birth date. Like finding fully developed cities where only primitive settlements should exist. Perhaps most troubling is the case of GNZ 11, a galaxy harboring a supermassive black hole already formed just 400 million years after the Big Bang, when the universe was merely 3% of its current age. Under conventional wisdom, such massive black holes require billions of years to form through multiple generations of stellar deaths or complex merger processes. Finding one fully formed so early is like discovering an ancient sequoia where you only expect seedlings. The timeline simply doesn't compute. This creates what physicists call a cosmic impossibility, the presence of mature structures at a time when they shouldn't exist. If these observations are correct, and Webb's instruments give us every reason to believe they are, our fundamental understanding of cosmic evolution requires a dramatic overhaul. Scientists are now exploring radical explanations. Could galaxies form at speeds previously thought impossible? Did unknown physical processes accelerate the birth of supermassive black holes in the early universe? Or might our understanding of the universe's age itself be fundamentally flawed? Some theoretical physicists suggest the universe might be significantly older than the currently accepted 13.8 billion years, potentially billions of years longer. Such a revision would represent one of the most significant shifts in cosmological understanding since Edward Hubble discovered the expanding universe. Alternately, perhaps unusual conditions in the early universe, higher densities, different physical constants, or other factors, created a cosmic fast track for galaxy formation that our models haven't accounted for. Webb's observations have effectively created a crisis in our understanding of galactic formation timelines. The textbooks that confidently outlined how galaxies form and evolve now appear to be missing crucial chapters, or perhaps telling the wrong story entirely. These impossibly ancient giants force us to question assumptions that have guided cosmology for decades. These anomalies force us to ask, is the cosmic story really starting with a bang? The crisis in our galactic formation timeline might be pointing to something far more profound than missing chapters. It might be revealing that we're reading the wrong book entirely. While astronomers have long treated the Big Bang as cosmic page 1, Webb's impossible discoveries suggest we might be midway through volume 3 of an infinite cosmic library. The Big Bang theory has served as the cornerstone of modern cosmology for nearly a century. According to this model, approximately 13.8 billion years ago, all matter, energy, space, and time erupted from an infinitesimally small, infinitely dense point. The narrative has guided generations of astronomers and physicists in their quest to understand our cosmic origins. But what if this seemingly definitive beginning was actually a transition point, a cosmic reset rather than a true genesis? This radical rethinking is gaining serious consideration among cosmologists grappling with Webb's impossible galaxies. The James Webb Telescope has discovered the most distant galaxy, GN-Z11, the most distant black hole, and the most distant quasar. Findings that collectively suggest our universe might be significantly older than previously calculated. Among the alternative cosmological models, attracting attention is Nobel laureate Roger Penrose's conformal cyclic cosmology, or CCC. Like a cosmic phoenix, this theory proposes that each universe rises from the ashes of its predecessor. Our universe could be just one chapter in an infinite cosmic story, with each Big Bang marking the transition from one cosmic epoch to the next. Penrose's model suggests that as the universe ages and expands, matter eventually disintegrates until only massless particles remain. This creates conditions mathematically identical to the Big Bang, triggering the birth of a new universe. The energy from evaporated black holes from a previous cosmic cycle could have seeded the formation of supermassive black holes in our universe's infancy, potentially explaining Webb's fully structured galaxies at impossible timeframes. CCC works entirely within established physics, simply reinterpreting what the Big Bang represents, a transitional moment when one universe transforms into another rather than an absolute beginning. Webb's findings may be forcing us to grapple with profound questions about the nature of time itself. If we're part of a cyclical cosmos, does it even make sense to speak of a beginning? The implications extend beyond cosmology into philosophy. Human civilizations have long wrestled with the questions of ultimate origins, typically concluding that something cannot come from nothing. Cyclic models offer an alternative, a universe that has always existed in some form. As Webb continues its mission, we may be witnessing a paradigm shift as significant as when Copernicus dethroned Earth from the center of the cosmos. Just as that revolutionary idea forever changed humanity's place in space, Webb's discovery may be redefining our place in cosmic time. We find ourselves at a pivotal moment in astronomical history. The James Webb Telescope isn't just offering prettier pictures. It's challenging the very foundation of our cosmic understanding. Astronomers face a potential paradigm shift that makes science truly thrilling. Consider what Webb's revelations mean to our cosmic timeline. Galaxy formation occurred impossibly early. New questions about dark matter and energy, potential rewriting of universal evolution. Like Copernicus removing Earth from the center of the universe, we may be witnessing another revolutionary shift in perspective. Are we part of an endless cosmic cycle? The universe keeps surprising us. That's the beauty of looking up. Share your cosmic theories below. Fascinated by these mysteries? Join Space Aquarius as we explore these astronomical frontiers together.